Hey everyone, welcome back to the course. In this video, I just want to go over some tips on how to get started with the second experiment on circuit theory and electronic test equipment. So here's the assignment, right? So we're going to be working with a DC power supply, decade resistor boxes, multimeter, function generator, and oscilloscope. And these are all, right, these are all new, right? We're just learning about them. And then we're also using our Arduino kit again. So lots to cover, lots of ground to cover this for this experiment. Let's just take a look at the exploration. So this first part, we're connecting two 10 kilo ohm resistors in series with a 5-volt source, right? So we're connecting it to a 5-volt source, and we're going to be using the decade resistor boxes and a DC power supply to do this. So let's just start off with a picture of like a diagram. All right, so here is our symbol for resistor. We call this R1, it's our first resistor. And here's our second resistor, R2. Right, and so these have their two terminal devices. And then here's our symbol for a voltage source. So it's going to be 5 volts. And these are going to be 10K, 10 kilo ohm each. And let's just take a step back. So looking at our connection, we are going to be connecting these two resistors in series, right? That means that we are going to take one of their terminals, connect it to the other resistor, but we are not going to make this kind of connection, right? If we make that kind of connection, then our two resistors are now in parallel. But what instead we want to do is apply our 5-volt source to one of these resistors, right? And then this other resistor, the end of this other resistor, R2, is going to be connected back to ground. So that's what we want to do for this first part of the exploration, right? So, and to do this, we're going to have our DC power supply, and we're going to configure it. DC power supply. And we're going to set it to 5 volts, right? And the DC power supply has some banana jacks. There's a minus and a plus, just like our voltage source. And then our decade resistor box, right? It has all the knobs, but it's also got the two terminals where we can connect, right? So there's a little drawing of where the resistor is. There's the two terminals, and here's like a little knob that you can turn or something like that. Kind of looks like that. And we've got two of these decade resistor boxes. And you just want to follow the schematic that you drew, right? So we take the positive end of our power supply, jump it over to one resistor, and then we jump the other end of this first resistor to the next resistor, and then we connect the negative terminal of our power supply to that resistor to complete the loop. So that's how we get started with the bench equipment, right? And it looks like, so we're going to have to measure the voltage across and the current through. So when we're measuring voltage, the voltage in parallel is the same for an element. So when we apply a voltmeter, right? So we have our digital multimeter, and this can act as a voltmeter and an ammeter, which measures current. An ammeter measures current. But when we want to measure voltage, right? So here's the symbol of a voltmeter. And say we want to measure R1. So our voltmeter, it's got two terminals. It's got a plus side and a minus side. We're not applying voltage. This is just the convention that that the voltage is in. So if you're getting a negative voltage, you probably just have it the voltmeter connected the wrong way, which is not a problem. But, right, so to measure the voltage drop across R1, we want to tie this plus end of our voltmeter there and the negative end of our voltmeter here, right? So then you should find that since we're up here, so suppose this is ground, right? Suppose the negative end of our voltage source is ground. So up here at this node is 5 volts. Now we can also take, so we've got this path, we've got the path from ground just straight through the 5-volt source. So then that's going to be 5 volts. But we've also got, so ground is also over here, right? This is also 0 volts right here. We've also got this other path that takes us up to 5 volts. So the voltage drop across R1 and across R2, if we add those two together, we should come to 5 volts. So, right, we've got our voltmeter, we measure R1, and I think I can just drag this, right? And then we bring it over here, and we can measure R2. And since these two resistances are the same, you should probably find that the voltage drop is 2.5 on both of them. Right, so let's just, let's move that back there, and I'll show you what that should look like. Right, so we've got our DMM and the lab, and it's got on the right, the top right corner, I can't really draw it on the top right, but it's got this ground, and then it's got another port, right, that says V and ohm, right? So if we use this top one, we can measure voltage and resistance, depending on what we set the digital multimeter to. And then down here, this is amps, and it's 3 amps specifically just for the maximum current limit. So this is a common ground that we share with the ammeter, but to connect the voltmeter to our circuit that we have down here, just erase this ground. Right, so we take this there, and let's use a different color. So we take V to the first resistor, right? So just like in the picture here, that would be this wire. And then we take the ground to the other end of that resistor, and that would be this wire. And that's how we would measure the voltage drop across that first resistor. Now, to measure current, we need to connect an ammeter in series. So, for example, we could insert an ammeter between R1 and R2, and to do so, we would have to get rid of this connection here, right? So we have our symbol for an ammeter, and an ammeter is also a 2-terminal device. And we'd have to connect this ammeter in series with the element that we want to measure the current for. So R1 and R2 are in series, so if we just put an ammeter in series with it, then we should measure, this will measure the current for both of them. So we have to connect R1, this terminal, to the ammeter, and then coming out of the ammeter, right, so this is like the plus end of the ammeter, and the minus end, or the ground, common ground. So coming out of the ammeter, we have this connection back into R2 to complete the loop, kind of. So let's just draw that over here, right? We have to get rid of this connection here, but we jump the resistor into the ammeter, come out the ammeter back into our circuit. So hopefully that's helpful. It's a very similar setup for the next part where we're using the, now let's just talk about it. So we have 3 10 kilo ohm resistors in parallel with the 5-volt source. Now we can go ahead and draw that. So yeah, just take these notes. I'm going to delete this. All right, so now we have our Arduino. It kind of looks like this, right? Arduino. And on our Arduino, we've got a 5-volt port. Yeah, and then there's also the ground on the board. And then you want to connect up a breadboard, but I'm just going to draw the resistor symbols because this should be kind of review from last week, hopefully. Right, so we've got our power rails. And that's kind of helpful. So we can just connect this 5-volt right to the plus power rail, and then the ground to the minus power rail. Right, so then we just have this line, and then to connect some resistors in parallel, I'm gonna need a little more space here. Right, so we've got our negative power rail and the plus. So to connect the resistors in parallel, we can just put them in between the power rails here. And then in order to measure voltage, right, so we have our digital multimeter again, and it's got the voltage ohm, and it's got the ground, and then it's got the 3 amps. So to measure the voltage, we just take this, connect them like this, and hopefully you'll find that the voltage across all of these, since they're in parallel, is all 5 volts. But then to measure the current, so this is going to be a little more tricky, right? So you actually have to take out one of these resistors, right? You got to pull one of the legs out, and then you probably got a banana to grabber and grab one end, grab the end of the resistor, take it into the ammeter, and then take it out of the ammeter and connect it back to the power rail. So that's how you would go about measuring the current. Another thing to mention when we're measuring resistance, we got to remove power from the circuit. So hopefully, let's see. So yeah, and that part should make sense now. Oops. Next, we have the function generator and the oscilloscope. Right, so you're just gonna you just have the two, right, scope and function generator. They just got BNC terminals. Hook them up together. You change settings here. And change the frequency and the amplitude and the waveform. And then on the scope, we've got the horizontal knob and the vertical knob. So the horizontal, this is going to be seconds per division. So when you turn the scope on, right, it's got these lines, and then here, whatever your time scale is, right? So let's say we've got like 1 millisecond per division, it's going to come up like that, just like 1 ms and then a slash. That means that from here to here is 1 millisecond, and then there's going to be a bunch of these vertical lines, and just in this horizontal scale, it's 1 millisecond per division. And there's also going to be a vertical. So depending on your scope, the scopes in the lab right now, they have 2 channels. So you need to change the vertical scale for each channel, or whichever channel you want to use at least. But this is going to be in volts per division. So it's going to be like V slash. And looking here, so we've got 0.5 volt sine wave at 100 hertz. So 100 hertz, right, that's a 1 by 100 is our period. So that's what, 0.01. Is that right? Yeah. Yeah, so 0.01, that's about 10 milliseconds. So you should be able to see your signal if we use 10 milliseconds per division. And then on the vertical, you're going to want maybe like 1 volt per division. And that should be sufficient. Or however you want to grab the screenshot is up to you. I just want you to understand the different knobs that are available. So if we know the frequency of our signal, you should be able to change the horizontal scale. And if you know how big your signal is, change the vertical scale. All right, moving right along. So here we have the base functionality. So we've got a potentiometer and we're probing the center tap with a digital pin and an analog pin. So let's talk about that up here. So we've got our Arduino, and inside of your kit is a potentiometer. It's a 3-terminal device. It's kind of got this knob that you have to go in and manually connect, but then on one end it's got 2 prongs. On the other end it's got a single prong. This is the center tap on the right, and this is where we apply our voltage, right? So we apply 5 volts and ground. Let's use a different color. 5 volts to there, ground to here. And then on the center tap, we want a digital pin and an analog pin. So let's just say we use A0 and pin 3, digital pin 3. And so we're going to connect that here, this also to here, and this will all be on a breadboard. So, just connect them on the same row. And then you'll notice, all right, let's just go back. So we're going to make a sketch that uses the serial monitor. So you're going to want to have to go and look up some example scripts for the serial monitor. Actually, yeah, in this part 4 of the exploration, we're using the serial monitor anyway. So you're going to look up some example code on how to print that out, maybe print out every second or so the value, the analog reading. And then there's some background on this as well, right? So if you have the Mega 2560 or 2650, I'm not sure what the order is. It's got an operating voltage of 5 volts. Our analog pins have an operating voltage of 5 volts and 10 bits of resolution, so that's 0 to 1023. Right, so as we turn this potentiometer clockwise, the resistance increases inside of it. And so that will make it so that there's an entire 5 volts being dropped across the 5 volts to the center prong. Okay. So basically, as we turn it counterclockwise, you should find that we have 1023 reading on the center pin, right, from our analog reading. And then as you turn it, I think it's clockwise. I could be wrong on the orientation here, but as you turn it counterclockwise or clockwise, basically one direction you should find that the analog reading is 0, and then the other direction, if you turn it all the way, you should find that the analog reading is 1023. Right, so that's the analog reading. What this assignment is also asking you to do is to probe the center tap with the multimeter. Right, so say we're just using the bench digital multimeter, and we want to record the we want to record the voltage across this center tap and ground. So we're going to take it from there to ground. And then in steps of about 100, right? So we've got analog, we started at analog 0. That's whichever direction you turn the potentiometer to get to 0. And then we drive it up about 100 each time and we record the voltage. And then we want to plot the voltage V, what is this? The center tap. Yeah, so we're probing the center tap. Let's call that VC as a function of analog reading, right? And so what this allows us is to create like a digital multimeter that can potentially be better than just directly converting this analog reading to a voltage in software. So that should explain these steps, hopefully. And then here, when we get to the pulse width modulation signal in series with the passive buzzer, so let's just draw that. So our passive buzzer, it's kind of like a two-terminal device as well. It's got a plus and a minus. And a pulse width modulation signal on your Arduino, if you look on the side, it should have like a tilde to indicate that it's pulse width modulation capable. So then we connect a resistor in series with the pulse width modulation signal, and then we tie this back to ground. And then we're going to connect that. And then we're going to figure out how to use this tone function to play that 490 hertz sound, and also the analog write function. And we're going to connect that to a scope, right? So we're going to get our scope. We're going to get a BNC to grabber cable, and we're going to probe. Let's go like this. So we're going to probe the buzzer, the signal going into the buzzer, and then on the other end, oh, I guess it's just one channel. So we're going to, with the positive end of our grabber, go there, and then this negative end is going here to ground. So hopefully that makes more sense. I know a lot of people were struggling today with the experiment. So I think next week we'll try to continue on with this assignment and go from there. Thanks for tuning in. See you next time.